So this is what we'll do in the demo of virtual service and destination rules. We'll create a service named app service with basic HTML page that outputs container for app or something else, whatever you like. Then we'll create one more service that'll output container for app 2. If you're talking about the business use case, the second service would hold the new feature that actually you want to push to production. And then finally, we'll create a virtual service that will divert 80% of the traffic to app service and 20% of the traffic to app 2 service. And this is my single YAML file for creating two services. Everything is same as a deployment. In the service, I'm creating a service of type cluster IP. Target port is 80 and service port is 8080 with some selectors. Similarly, in the second one also, this would be for deployment for app 2, and this would be the service for app 2 with named app2-svc. The target port is 80, and let's say we keep the service port also as 8080. This is also possible, by the way. So we'll use this to create our two services and deployments. So both the services and deployments have been created. Let's take a look. Now these are the two services. If we use cluster IP, we should be able to get the output. So it says this container is for app, istio demo app. Same would be the case with the other one. Now, can we do that using the name of the service? I should give error because it will say that host cannot be resolved. You know what to do here. You have to change the resolve.conf file to point to the pods which are running CoreDNS. I have made changes in resolve.conf. Now it should work. If we do a curl, we should be able to get the output. So this is app svc, and then we should get the output for app2 svc also. So both are working fine. One is app and the other one is app2. Let us create the virtual service for routing rules. So I want 80% of the traffic to be diverted to this service, and remaining 20% of the traffic should be diverted to this service. Now, even though the name of the services are different, whenever I use this endpoint, 80% of the traffic should actually go to this service itself, and the remaining 20% should go to this other service. So how do you do that? Using virtual service. Now this is the file istovsdr.yml. It'll find it in the resource section. So of course the API version is networking.istio.io/v1 beta 1. The kind is virtual service, and in metadata I have mentioned the name of the virtual service. Now in specification, of course, I have hosts. Now this is the host. So it means that this routing rule, or whatever routing rules we are mentioning here, would be applied to the service whose fully qualified DNS name is this one. Even though I have two different services, that is fine. So any traffic that is directed to this particular service, this routing rule would be applied to all those traffic. So after hosts, I have HTTP, and this is the name of the routing rule, virtual service routes. And then we have route option, wherein we mention multiple destinations. As of now, I have only two destinations. If you want, of course, you can have more than two, or you can have one also. Now in the first destination, I'm sending the traffic to this service itself, and the way it will be sent is using subset, and the name of the subset is app service subset. And the weight I'm mentioning 80, that means 80% of the traffic should go to this subset and this service. Now we have second rule, wherein the host is app2-svc and the weight is 20, and the subset is app2-service-subset. So from here till here, this routing rule means that traffic that comes looking for this service, 80% of those traffic should be sent to this service with this subset, and remaining 20% should be sent to this traffic with this subset. So as you have two subsets with two different services, we'll have to create two destination rules. I could have used a single service also, which we'll see later on. So here I have two different services. One is app svc and the other one is app2-svc. So that's why I'll have to create two destination rules. And I mentioned the destination rules in the same file. So this is the first one, and API kind metadata is pretty similar. In spec, I have host. So this destination rule is for app SVC. And this is the name app service subset. And this name is actually the name which we have provided in the subset of destination option. So the first destination option, I have mentioned the subset to be app service subnet, and this destination rule is for that subset. And labels are actually selectors. I'm selecting the pods with all these labels. And then in traffic policy, I have mentioned load balancer, simple round robin. I'll have to create one more destination rule for app2 service. Now API version kind metadata is same, but here there's something wrong. So I have not mentioned spec, host, and subsets. So this is the specification, and it should be for app2 SVC, this destination rule. And then the subset is slash name. This is the name of the subset, and these are the selectors. And then you have traffic policy. So let us go ahead and create this virtual service with two destination rules. All right, so the virtual service and two destination rules have been created. Let us go ahead and take a look. You can mention the entire name virtual service or the short form VS. I use VS because virtual service by itself is pretty long. So this is the virtual service that has been created. Let's do a describe. And if you see, these are the destination rules. There are two routes, one to host app service and the other one to host app2 service. Similarly, you can get the destination rule using dr. These are the two destination rules that we have. Of course, we can go ahead and describe it. Now it says that the first destination rule is for host app service and the second one is for app2 service. And this is the destination rule, and here the specification. So there's nothing much here. Okay, now let us go ahead and see whether it works or not. Okay, so curl is working. Will it work? Will it send 80% of the traffic to app and remaining 20% to app2? So let us run a while loop. Okay, let us take a look. 1 2. Okay, so some time has passed, and the thing is that it is not sending. So I'm scrolling up. So it did not send a single traffic to app2. Now the reason is that if you see and if you notice, I'm sending the traffic. I'm trying to access the traffic from the master node, not from the pods. So that's why it is sending only to the service itself. I'll tell you the reason diagrammatically later on, but let us try it out from any one of the pods. Now I'm inside of the pod. Let's take a look now. If I run the while statement again with curl in it, what happens? So now you see one traffic went to app22, then one more, some amount of traffic is actually going to the second app. So seems like our virtual service and destination rule are working. Let's stop this and see what is happening here. So this is where it started. This traffic has gone to app22. This request has also gone to app2. Similarly, some other. So it is doing some amount of traffic distribution based on the virtual service. Might not be accurate, but it is doing some amount. So it is actually working from inside of the pod, but of course it did not work from outside of the pod or from the master node. But anyway, our virtual service is working. So let's try to find out why it did not work from the node itself, but it worked from the pod. I can go to any other pod which is part of the STO service mesh, and if I try to connect to this service, 80% of the traffic should go to app service and 20% of the traffic should go to app2 service. So it is working. So this is what happened, why it wasn't working. And this is our node, right? And we have multiple nodes, one master node and one worker node. We created one application container with the name app and created a service for it. Similarly, we created another service or another deployment with another application. And these applications are managed by the STO service mesh. But the problem is that when we ran the curl command using the service name, we ran it outside of the service mesh. So I was running the curl command from the node itself. So when I ran this curl service name, So it went out and checked the core DNS server or the cube DNS, whichever you want to call it, and it was resolved to the service IP address and then went to the service and did a load balance across the pod. So you see the problem here, it was never able to connect to the envoy proxy. So as it was not able to connect to envoy proxy, the routing rules were also invalid. The routing rules were also not applied. But when you used it from inside of the application container, it had to pass through envoy proxy where the routing rules are set using virtual service and destination rule. And it's true for both the application containers. If we run it from another pod also, we'll see the same behavior. So as it was running from inside of a container, it went through envoy proxy and the routing rules were applied. So does that mean that we cannot use the routing rules outside of the cluster? Something like this. The answer is no, we can do that. We can use something called ingress gateway, which will allow traffic from outside of the cluster to behave using the routing rules, which we'll see later on. But as of now, this is what happened. So this was the reason that the routing rule was not applied from the node, but it worked from inside of the pod. Let us see a few more demo, a few more configuration of virtual service and destination rule. Then I'll go ahead and discuss a few other components.